evaluate the integral. Integral tan cube t secant cube t dt. Well, in order to do this, you must have a fair idea of the derivatives of trigonometric function. Well, the way to think about this is tan has the odd power, secant has the odd power. Now, therefore, it is convenient that we take a tan t secant t from here and write it as tan squared t secant squared t times secant t tan t. Now, does a bell ring for you when you hear secant t tan t? What is the derivative of secant u or secant x? The derivative of secant x is secant x tan x. That means if you have a secant t tan t there, that is going to act as du for some substitution. What must be the substitution to get that as your du? The substitution must be secant t equal to u. That means you need to change that tan squared t to secant t using one of the identities. Alright, so look at the way we're going to write this. Tan cube t secant cube t is written as tan squared t times secant squared t times tan t secant t. You must understand the rationale for doing that. We did that because we can change tan squared in terms of secant squared. So all these can be written in terms of secant squared t or secant t. And then if you want to make a substitution secant t equal to u, then you need a tan t secant t. Alright, how do we change tan squared t in terms of secant squared t? What is the identity that helps you do that? 1 plus tan squared t equal to secant squared t. That means tan squared t is secant squared t minus 1. You've got to learn those. You've got to make it your own. It's very important. So 1 plus tan squared t equal to secant squared t. Therefore, tan squared t is secant squared t minus 1. So let's replace this tan squared t as secant squared t minus 1. So that will be secant squared t minus 1 times secant squared t times tan t secant t. Well, we are now ready to go, because now we can substitute secant t equal to u. Then du will be secant t tan t dt. Alright, let's now take the integral and deal with it. So, integral secant cube t tan cube t is now, look at this, I also distributed the secant squared t. This is secant to the power of 4t minus secant squared t times secant t tan t. And it is this quantity that we simplified like this. Therefore, integral secant cube t tan cube t is the same as integral of this quantity. Integral of secant to the power of 4t minus secant squared t quantity times secant t tan t dt. We are now ready to do our substitution. What is our substitution? Secant t equal to u. If secant t equal to u, find the differential of both sides. The derivative of secant t is secant t tan t. So the differential of secant t is secant t tan t dt. There you go. Secant t tan t dt equal to du. When secant t becomes u, secant t tan t dt becomes du. So this now becomes u to the power of 4 minus u squared du. And now we can integrate it. You see how such a form is made simple by this identity manipulation. integral u to the power of 4 du is u to the power of 5 over 5 minus integral u squared du is u cubed over 3 plus c. And now replace your u. What's your u? U is secant t. So that will be secant to the power of 5t over 5 minus secant cubed t over 3 plus c is the result of that integration. Alright, let's try another one. Evaluate the integral tan cube 3x dx. Tan cube 3x dx. Well, that's something different, is that right? Different from what we have seen earlier. Well, so what we first do is make a substitution. 3x equal to u, and that will give you 3 dx equal to du, or dx equal to du over 3, and this will become integral tan cube du over 3, or 1/3 tan cube u du. And what is our next step? Well, we write it as tan cube is written as tan squared u tan u du. And what can we do from there? Write tan squared u. See, 1 plus tan squared u is secant squared u. So tan squared u is secant squared u minus 1. Well, that's now simple. Now it looks simple because you can integrate tan u secant squared u. Is that right? Now let's distribute that. That will be 1/3 integral secant squared u tan u minus tan u du. Can you integrate this? What is integral secant squared u tan u? You need to make a substitution there. You see, to integrate this, what substitution will you make? Look at that, secant squared u du. Secant squared u du is the derivative of tan u. So we make the substitution tan u equal to, since we have already used u, we cannot use u, so we use something else. Maybe we can use v. Alright, so what we do is, we say 1/3 secant squared u tan u du minus 1/3 of integral tan u du. We write this as two different integrals. This is integral secant squared u tan u du minus 1/3 tan u du. And here we need to make a substitution here. Substitute tan u equal to v. That makes secant squared u du equal to dv. That means secant squared u du will become dv. So we have 1/3 integral secant squared u tan u du minus 1/3 tan u du. This is the one we can do with that substitution. What does that become now? That will be 1/3 of v dv. Is that right? Secant, we have tan u equal to v. Then secant squared u du become dv. So it's v dv. And this can be integrated. Tell me, what is integral of tan u du? Integral of tan u du is, well, we had the integration formula, is negative ln cos u. That's right, you should know that. So this will be minus 1/3 negative ln cos u. Alright, so this becomes 1/3 integral v dv, which we will leave it like this, we will work it out in the next part, minus 1/3 integral tan u du become negative ln cos u, and the two negatives will become positive. Now 1/3 integral v dv is v squared over 2. So 1/3 times v squared over 2 plus, become plus because of the two negatives, plus 1/3 ln cos u. Now that will be v squared is tan squared u, is that right? 3 times 2 is 6. Our original substitution, our v is tan u, so you got v squared become tan squared u over 6 plus 1/3 ln cos u plus c. But what is this u? We started in the beginning calling 3x equal to u, so you need to replace that u again to get our final result. So replacing u, we get the answer will be tan squared 3x over 6 plus ln cos of 3x divided by 3. That is 1/3. This 1/3 is put in there. So that's the final result in here. Now I want you to go back and look at this one more time and go through the drill of these steps. Very important to practice that. Alright, let's go and do another one. Solve the differential equation.